Hi folks, today we're going to talk about our second special right triangles topic. And so in the last set of notes we talked about the relationship between the sides in a 45, 45, 90 degree triangle. And we discussed the theorem, we practiced problems. Today we're going to discuss the relationship between the sides in a triangle that has a 30 degree angle, a 60 degree angle, and a 90 degree angle. And we call these triangles 30, 60, 90 triangles. So in a 30 degree, 60 degree, 90 degree triangle, the hypotenuse will always be 2 times the length of the short leg, and the length of the long leg is the short leg times the square root of 3. So in our figure, we have the right angle that's given to us. I'm going to go ahead and declare that this angle right here is a 60 degree angle. And so the triangle sum theorem, we know that if this is 60, then this must be 30 degrees. So I gave this to you and we can conclude that this is 30 degrees. So we've got a 30, 60, 90 triangle. And we'll notice that right across from the right angle, we have the hypotenuse. But then we have 2 legs, and in a 30, 60, 90 degree triangle, you'll always have a short leg and a long leg. And so the short leg will be opposite the smallest angle, so that would be right here. This is the short leg. And the long leg will be opposite the 60 degree angle, so that would be this side right here, side CB. So this is the long leg of the right triangle. So whenever you label these sides, we're going to go ahead and label them in terms of the short leg because we were able to talk about what the hypotenuse was in terms of the short leg and what the long leg was in terms of the short leg. So the short leg, we're going to go ahead and give a measurement of S. So AC has a measurement of S. It says that the hypotenuse is 2 times the length of the short leg. And so if the short leg is S, S for short leg, then the hypotenuse will be 2S. So AB is 2S. And then finally, the long leg is the measure of the short leg times the square root of 3. Well, if the measure of the short leg is S, then the long leg's measure is S square roots of 3. So we have S, S square roots of 3, and 2 times S. So in our example, my screen's not big enough to hold all of that in there, but be able to put this. Example 1 says find the height in terms of x. So remember that you're calculating something for the height, we'll call it h, and it's going to equal something with x. Not an actual number, not a whole number, not an integer. It's going to equal an expression that has x in it. That's what it means to be in terms of x. So I see that I have a 60 degree angle, a 60 degree angle, and by the triangle sum theorem, this must also be a what? Must be a 60 degree angle. And I'm supposed to find the height in terms of x. Well, the height is going to go from the vertex all the way down to the opposite side and create a right angle. Well, if this is 60 degrees and this is a right angle 90 degrees, then what is this piece of the triangle going to measure? This extra angle is 30 degrees. And we have a triangle over here that is congruent. It's got the same side lengths. So the angle measures will also be the same, 90, 60, and 30 degrees. So we have 2 30, 60, 90 degree triangles. We're asked to find the height, which is this drawn in segment here, so we're going to label that H. And then this large triangle, not the 30, 60, 90 degree triangles, but the large triangle is equiangular, which also coincidentally means that the triangle is equilateral. So if one side measures 2x, then all sides measure 2x. I also know from information from last semester that this segment right here, because it's cutting the 60 degree angle into 2 congruent angles, well, that means that it's an angle bisector. That also means that it's cutting this segment into 2 congruent segments. So from here to here, that segment is congruent to the segment from here to here. And if the whole length is 2x, well then each of these must be x. So, this is all information that we know from last semester. These are all things that we could put in, we could draw in, and we could draw conclusions from. Now our new information tells us that in a 30, 60, 90 degree triangle, we have some relationships between the sides. We have the short side, s, we have the hypotenuse, 2s, and we have the long side, s square roots of 3. Now remember that everything is going to be in terms of x, so we are not really going to treat x as a variable. We're going to treat it as a value. So here I have that s is equal to x. So what I can do, if I have this relationship, is that I can find my height in terms of x. So I can take this value right here, and since it is equal to s, I can substitute it for s. And h is equal to x square roots of 3. This is the height in terms of x. Now, without knowing this relationship, you still could have continued with this problem. You could have used the Pythagorean Theorem. You could have substituted your pieces that I have written in pink. So we have h for a leg, we have x for a leg, we have 2x for the hypotenuse. So we could have continued solving. We could have moved the x squared over to the other side. And then we also could have square rooted to find the value of h in terms of x. Well, the square root of 3 doesn't get simplified, but the square root of x squared, those will cancel out, and I'll just have x, square roots of 3. So we have the opportunity to use either one of these, but if you know the relationship between a 30, 60, 90 degree triangle sides, this is definitely the more desirable amount of work. So let's move on to our next page. Example 2 says, find the value of each variable, give your answer in simplest radical form, and always label the triangle. So I need the value of each variable in simplest radical form. For problem 2a, I have an x and a y. So my answers are going to be x equals and y equals. This is what I'm looking for. So let's look at our triangle. What kind of triangle is it? Well, it's a right triangle. It's got a 30-degree angle here. So the triangle sum theorem says this must be 60 degrees. I have a 30, 60, 90 degree triangle, so I want to label the triangle with the information that I know. I know that the short leg is s. I know that the hypotenuse is 2s. And I know that the long leg is s square roots of 3. Now in the last set of notes, you always wanted to start where you had an equation with only one unknown, one variable. So here we have an x and an s. That's two unknowns. We can't use that first. Here we have an s and a y. That's two unknowns. We can't use that. Here we have just s. And so we can start out with this equation. If s equals 9, then let's talk about this. What can you do with 9 in this equation? Well, if s is equal to 9, you can substitute 9 for s. So y equals 9 square roots of 3. That is as simplified as it gets, so we can go ahead and write our answer. We also can use this equation, x equals 2 times s. Well, if s has a value of 9, we can substitute 9 for s. And 2 times 9 is 18. That is as simplified as it gets, so x equals 18. So start out with a piece of information that has one variable and use it in the other two equations. Let's look at B. B has a right triangle with a 60-degree angle. The other angle must be how many degrees? 30 degrees. Go ahead and pause your video and label your sides. You should have the short side s, the long side s square roots of 3, the long leg s square roots of 3, and the hypotenuse 2s. Find the equation that only has one unknown, two unknowns, one unknown. So this is where I'm going to start. I'd like to find the value of s here, so I'm going to divide by 2, and s has a value of 7. So if s equals 7, then x equals s means I can substitute 7 for s. So x equals 7. There's one value. Let's look at the other equation. Y equals s square roots of 3. I can substitute 7 for s, so y equals 7 square roots of 3. That is in simplest radical form. And I have the measurements of my two variables. So I'm going to ask you to pause your video and try example 2c. Check back for the work. In this problem, if you got stuck, I bet it wasn't labeling the sides. So we have s square roots of 3, and 2s. The equation that only has one variable is this one right here, so that's what we start out with. We're going to solve for that variable. When we solve for the variable, we get a radical in the denominator, which we can't have. It's not good form. So we need to rationalize the denominator by multiplying numerator and denominator by this radical. When you multiply, 12 times square root of 3 is 12 square roots of 3. Square root of 3 times square root of 3 is square root of 9, which is just 3. And then 12 over 3, those coefficients can be simplified to make a 4 as the coefficient to the square root of 3. So s is equal to 4 square roots of 3. And if that is the case, then y equals s means y equals 4 square roots of 3. And x equals 2 times s means x equals 8 square roots of 3. So these are your two variables values. So let's move to our last page today. It asks us to find the perimeter and area of triangle ABC. So triangle ABC is this large triangle you see here. It asks you to leave your answer in simplest radical form. So that's what we're going to do. Now, this does not look like anything that I am familiar with. In our special right triangles notes, we've talked about 45, 45, 90 degree triangles, and we've talked about 30, 60, 90 degree triangles. We've not talked about 30 degree, 105 degree, and whatever this degree is triangles. So we do need to create some right angles here, and in order to do that, the best way is to start from a vertex and go straight down until you create a right angle with this other side. So now we have a 30 degree angle, a 90 degree angle, and this angle right here must measure 60 degrees. Now, this is also 90 degrees. This angle measure right here is whatever 105 minus 60 is. So 105 degrees minus 60 degrees gives me 45 degrees. So this angle measure must be 45 degrees. And coincidentally, we're familiar with that. We should have a 45 degree angle, a 90 degree angle, and another 45 degree angle. You could always double check to make sure that you have the right angle measures by adding the angle measures of the large angle, of the large triangle. So 105 plus 45 plus 30. If you add them all up, you should get 180 degrees, which we do. So we've got two triangles here. Let's go ahead and split this into two pictures. So the first picture we will deal with will be the 30, 60, 90 degree triangle. So I went ahead and put in those measures. I'm also going to go ahead and put in that the length from A to B is 16 because that's given. Now the second triangle is a 45 degree, 45 degree, 90 degree triangle. And we have no other information for this one. So I've drawn my pictures. I put in as much as I possibly can. I do want to remember, though, that I'm not finding side lengths. What I'm finding are the perimeter and the area. So I'm going to go ahead down here, and just to remind myself of what it is that I'm finding, I'm going to go ahead and put P equals and A equals, so that I remember later on that my answers aren't just side lengths, they're the perimeter and the area. So in order to find perimeter and area, the perimeter equals all the side lengths added together. So side AB plus side AC plus side BC. The area equals 1/2 of the base, which is going to be CB or BC, times the height of this triangle right here. So we'll call this H, because we don't really have a point here to name this segment with 2 points. So keep that in mind, that these are the final things that we're looking for. Now, obviously we'll start with this triangle because it's the one that I wrote first, but if it wasn't the one I wrote first, how would we know to start with that one? Well, it's the only one that gives us any kind of measurement for a side length. So this is the one that we have to start with. In our 30, 60, 90 degree triangle, my short side is across from the 30 degree angle. We're going to label it S. My long leg is across from the 60 degree angle. We're going to label it S square roots of 3. And then the hypotenuse is across from the 90 degree angle. We're going to label it 2S. So find the equation, and there's only one equation, that has a single variable. That would be this one right here. These two don't tell us much of anything. But 16 equals 2S allows us to solve for S by dividing by 2. So S equals 8. Well, what that means is that this side over here equals 8, and this side down here equals 8 square roots of 3. So I'm going to go ahead and insert that into my picture so that I know what I'm looking at. So if this is 16, this right here is 8 square roots of 3. And this right here is 8. Now, it just so happens that this measurement of the height, which is 8, also appears in this triangle because it's a shared side. So I'm going to go ahead and insert that into this diagram. This is 8. Now, what do you know about 45, 45, 90 degree triangles? Well, we know several things about them. We know that they're isosceles right triangles. So if this side has a measurement of 8, well then this leg over here also has a measurement of 8 because the legs are congruent. Now we also know from the previous lesson that this leg we label L, this leg we label L, and the hypotenuse we label L square roots of 2. So all of these only have one variable. However, L equals 8 defines something. So if L equals 8, well then this side over here would be 8 square roots of 2. So I'm going to go ahead and put that in my diagram, that if this is 8, then this is also 8. And this here is 8 square roots of 2. So now let's talk about the perimeter and the area. So the perimeter we have the length of AB. That was given to us as 16. We have the length of AC. That we found out to be 8 square roots of 2. And we have the length of BC from here to here. Now this is a little bit tricky because it combines a side that's 8 and a side that's 8 square roots of 3. So we're not going to multiply those together. We are simply tagging on one segment to another. So we are going to add those two lengths. So we have plus 8 square roots of 3. Now, when I put these together, I can only combine things that are like terms. And so the things that are like terms would not be the things with the radicals because this radicand is a 2 and this radicand is a 3. So these are not like terms. But the 16 and the 8 are like terms. So 16 plus 8 is 24. And then plus you have the 8 square roots of 2 term and the 8 square roots of 3 term. So that is my perimeter. I'm going to go ahead and include that in my box for my answer. and think about the units that we are measuring this triangle side in. Did it give us any units? No, it didn't. And so we're going to go ahead and just put U for units, but we don't want to give it to this last term. We want to give it to all the terms. So in order to do that, we correctly insert our answer in parentheses and give units at the end. So now let's talk about the area. The area formula is 1/2 times the length of the base. Well, the length of the base was 8 plus 8 square roots of 3. And then times the height, which we found out to be 8 units. So when I do the multiplication, you have two choices. You can either multiply the 1/2 times the 8 and the 8 square roots of 3, or you can multiply the 1/2 times this 8. And it really doesn't matter which one you do. I have a habit of multiplying these two single numbers first, so 1/2 of 8 is 4. And when I multiply it times this sum, I'm going to multiply the 4 times the 8 and the coefficient here. So A equals 32 plus 32 square roots of 3. And when I write that as my answer, I have 32 plus 32 square roots of 3. I want to measure in units, but not just units, units squared, because it's area. And then I also want to make sure that I apply the units squared to both terms, so I'm going to put these in parentheses. So in summary, we now have another set of triangle measurements that we can name a certain relationship for the sides. So in the past, we talked about 45, 45, 90-degree triangles, and now you know the relationship between the sides of a 30, 60, 90-degree triangle.